Hi, I'm Brian Alverson. I'm a professor of pediatrics over at Brown University. I wanted to talk to you for a little bit about COVID testing and why it's so confusing during this outbreak. So COVID-19 is a virus, a kind of coronavirus that goes into our bodies and attacks our cells. Then it makes copies of itself, billions and billions of copies, using the machinery on our own respiratory tract, and then it comes out of our body to infect someone else. That can go out of our body through coughing, or sneezing, or talking, or even singing. Because the virus is making so many copies inside our bodies, we can use technology called polymerase chain reaction, or PCR technology, to determine whether it's actually there. Basically, COVID has RNA, sort of like DNA, which is inside it that gives it the instructions on how to survive and attack people. We can find RNA that is specific to only COVID-19 using PCR technology. So this is an extremely accurate test. To get this, what we do is we take a swab and put it deep inside your nose and rattle it around in there and try and get some of the virus. Then we send it off to the lab and see if there's COVID-19 on there. We put the swab that we've collected into a machine that makes tons and tons of copies of this virus so we can see if it's actually present, even if we only got a tiny, tiny amount of virus on the actual swab. Let's take a look for a second and see how that technology works so we can really understand COVID testing. Let's pretend I had a penny and I had a machine that could double the number of pennies I have. So if after one time through the machine, now I have 2 pennies. Another time to the machine, now I have 4 pennies. Another time through the machine, I have 8 pennies, and this continues over and over again. If I did this 30 times, how much money would I have? 100? 200? 300? Nope. I would have well over $10 million. So this is what we can do to make sure that we find a copy of this virus. So when people say the coronavirus test is accurate, when they're talking about the PCR test, what they're saying is that even if there's a tiny, tiny, tiny amount of virus, we're probably going to pick this virus up. When we say accuracy, that's probably not the best way to describe a test. Probably the best way to describe a test is to ask how sensitive it is and how specific it is. Let me explain. A test that says it has high sensitivity means that if you have the virus, the test is almost definitely going to be positive. And a test that has a high specificity tells you that if you do not have the disease, the test is almost definitely going to be negative. Now we think, boy, sensitivity is more important, but in fact it's the specificity, or the ability for the test to see who's healthy, where we get in a lot of trouble. If a test isn't specific, the problem is it's going to be positive when you don't have the disease. The issue with that is that you're going to have what we call false positives. In other words, you're going to get a positive test, but the person doesn't have the disease. So the great thing about this PCR test is because it's so only looking for COVID-19 RNA and nobody else's RNA, it's very specific. If you get this test and it's positive, there's no way it got it from something else. So this is an extremely specific test. But how sensitive is it? Part of the problem is it depends on how well you swab the nose. It also depends on whether the person is still shedding the virus from their nose. What if they're shedding it from somewhere else, like their poop, which can happen. So part of the problem is we all seen patients with COVID where we've swabbed them multiple times and it wasn't until the 4th or 5th time that the test turned positive. So the issue is, and this is a squirrely one, is how do we know how sensitive a test it is if we don't have another test to compare it to? For instance, if I could go to God and say, give me all the people with coronavirus, and then swab them all and the tests were all positive, I would say it's a good test. But what if only half came back positive? The problem is I don't have God telling me who has coronavirus. So the challenge here is that it's very hard for us to guess as to how accurate this test really is. We think it's very specific, but we're not really sure how sensitive it is. And I don't see a real way we can figure that out right now. Another problem comes when we start using this PCR test, like you're seeing in the news, to tell us how many positive cases there are. So for instance, last week, there was a report that the U.S. passed 50,000 cases a day.
The United States, once again, is heading into record pandemic territory. Yesterday, officials reported more than 50,000 new infections nationwide.
These are PCR tests. So 50,000 people got swabbed and had a positive result. We're pretty clear that there were at least 50,000 cases. The question is, were there more than 50,000 cases? Were there people who were positive who were tested and it was negative? Or even worse, were there people who have the disease but were never tested? Were there thousands and thousands of people who were asymptomatic who had the disease and weren't tested? Let's do a thought experiment for a second. Let's say we have 1,000 people in one state. There are 10 sick people in the state, and they have come to the doctor for a COVID test. We tested them, and 5 of the 10 are positive. But what if none of the people who are healthy have the disease? Well, then the rate of the disease in the population is only 0.5%. But what if it's very common to have this virus in your nose, but have no symptoms at all? If only 1% of the population with this virus get symptoms, well, then a huge number of people are going to have the virus in their nose, but not even going to get tested. If only 1% of the people who have the disease get symptomatic, well, then the 5 people with the disease that we tested who were symptomatic are only about 1% of the population. And in fact, there are 500 with the infection, and literally half of the entire population has the virus. There are viruses that do this. An example is cold sores. The cold sore is caused by a virus called HSV1. Not everyone gets cold sores, but would you believe that 95% of you are actually positive for the virus right now? So the problem with COVID then is because we haven't tested a huge number of people in the population who are completely healthy, we really don't have an idea of how prevalent or common this virus is. Why don't we do that? Well, there's some problems with that. The problem is that in every state there's probably a different prevalence, and we'd have to bring in thousands of healthy people to swab their noses, and they might not want to do that and perhaps expose themselves to medical people who might give them COVID. But also, the issue is that the number is changing so rapidly as the virus spreads that it's completely impractical to be constantly swabbing healthy people to figure out what the prevalence of the virus in fact is. So despite what you're hearing in the news, the reality is while a PCR test is not an unreasonable way to check to see if you have the virus, we think it's fairly sensitive and it's definitely very specific. The problem is that it's a real bad way to see what's going on in the population in terms of virus spread. So some people have claimed that because of this, we should do less testing. Probably that's not true. The more we test, the better we have a general idea of how things are going, but you can't really trust the numbers entirely. And this confusion, I think, leads a lot of people to wonder which way should we go on this issue. Probably more testing is better. But what about antibody testing? Is that the way to see how common the virus is in a population? Is that the way to see if you're immune to the virus? I'm going to answer that in the next video.